vi dela upp det här så att vi kör så. Ja, man börjar du med det här.
Sen så bara så brukar vi sång and dance. Eller Sebastian, sätt sig.
Okay, let's start. Welcome to this seminar about citizen science. I'm Daniel Slunge. I'm here at the Department of Economics and also at the Center for Environment and Sustainability. And also part of BEC, which is a strategic research area between the University of Gothenburg and Lund University. And we have a small action group on stakeholder interaction in research processes where we try to learn more about effective interaction. And we're also working on kind of a guidance for stakeholders or for researchers how to involve stakeholders. So in that context we have this small seminar series where this is the third seminar. And now we're very interested to hear about citizen science. And for that purpose we have Dick Kasperowski and Kristoffer Kullenberg from Theory of Science. And you're going to present for about 20-30 minutes, and then we'll open up for questions and discussions, and we can follow up with more examples, etc. etc. Also welcome to those of you who are joining us via link. And if you have any questions, you can email to maria.guthberg@gu.se. And we will forward those to Dick and Kristoffer. Okay, so very welcome.
Daniel,
yes.
Can you put off the lines?
Yes, we might dim it a bit. Wait, is this too much?
No, much better contrast.
Yes, it's difficult to get that one out. That one is good.
No, but that's okay now.
It's okay?
Yeah.
So it's a little bit dark and cozy. That's nice. Okay.
November feeling.
Yeah, November feeling. Yes. My name is Dick Kasperowski and Kristoffer Kullenberg. We're here to talk about something called citizen science, or in Swedish, medborgarforskning seems to be the concept used in Sweden. In Germany, Bürgerwissenschaft, and there's a different conceptions around the world. But citizen science, representation and participation in research, and we'll go deeper into these, the conceptualizations of representation and participation later. Citizen science is currently invested with a lot of expectations on the policy level, both nationally in Sweden and particularly on the EU level. And this is from the Society's white paper on citizen science for Europe. This is from 2014, a couple of years ago. And you can see that there are enormous expectations on citizen science. Citizen science is about involving the non-scientist in scientific work. And where in the research process can you involve people in scientific research? That's the question that we are interested in. So here are some of the expectations now. It's co-creating a new scientific culture. Volunteers acquire new learning, a deeper understanding of the scientific work. Society policy interactions are improved, and we get a more democratic research. You can all contest these expectations. Some of them are very high, and some of them we are not sure if citizen science can fulfill, but maybe some of them. And just recently, this was spoken by Carlos Moedas at a conference in Manchester in July. Now, there's a difference between these two kind of expectations. This is expectations about changing science to a more democratic science, to more inclusion. But this is about using citizen science as a vehicle to remedy something that is wrong with society. Populist fears and assumptions, science and politics have left larger parts of the public behind. Citizen science brings citizen scientists closer to the people. So it has changed from going to change scientific research to change society now. There's a difference between the expectations that has evolved during the last 2 years. But science, there are great expectations in science for involving the non-scientists in research. And Christopher will take you through these figures here.
So from a policy perspective, we have these expectations on the democratization of science, etc. But from a scientific point of view, if you look at, and this is from one of our studies, scientists have other expectations. And most of these expectations on citizen science are being able to collect and classify large amounts of data. So you have very similar expectations on citizen science as you have on, for example, crowdfunding. And so some even call citizen science crowd science from this perspective, that you can get very cheaply, you can get a lot of observations or classifications, and you can perform types of scientific work that are not possible to do by researchers alone. For example, covering large geographical areas, collecting species observations, or classifying large digital repositories of scientific data. So if you look at this picture shows the growth in scientific publications, that scientific publications using citizen science as a method. And since around 2009, 2010, we have seen a large growth in scientific publications. And this can be explained partly by many projects utilizing the digital platforms and using online interfaces to expand the possibilities of interacting with large numbers of volunteer contributors. So even if citizen science has a long history going back even 100 years, with the rise of social media and Web 2.0 platforms, the transport layer for collecting and classifying data, the infrastructure for doing citizen science, has become very much cheaper and much more readily available. And
maybe I should say just the long history of citizen science has been invoked with the question of data quality, of course. How can you rely on the non-scientists when you collect or when you observe or classify large amounts of data? How can you assure the data quality? So, and when universities became professionalized in the beginning of the 1900s, exceedingly professionalized, the citizens or the volunteer contributors were made invisible in publications. For instance, in ornithology has been very important for ornithology. It's very much about stars and birds. Ornithology and astronomy has been very, very influential when it comes to citizen science. They have involved citizens. But they have been made visible because there has always been a question of the data quality. But now there seems no stopping the visibility of the outsider into science. Today it seems to be almost a mark of quality if you can involve as many as possible in the scientific work. And it goes together with concepts like RRI, Responsible Research Initiative, and open data, the lure of open data. So now they are kind of mobilized in enormous numbers now to be included in science, which was not the question before. You made them invisible. So sorry, Christopher.
Another way of looking at what citizen science is, if you look at the point of view of scientific publications, you get, and it's very difficult to see here because it's, but if you have this printed on paper, it's easier. But we ask the question, which scientific disciplines or which areas of research have involved citizens in their projects? And this big citizen science, this big cluster over here, this is a keyword co-occurrence analysis. So if the scientific publication has citizen science as a keyword, all the keywords here that are related will be attracted to this keyword. And if you could magnify this, you would be able to read that here, this sort of field of research here is very much based on environmental science and species conservations, biology, zoology, and various types of research that study the biological nature. And over here, you see another keyword here. It says public engagement. And this is another strand of research which is more policy-oriented, and where social scientists investigate the relationship between science and the public, and science and various stakeholder engagement. So you would find here keywords such as public understanding of science, science communication, etc. This type of social scientific research, which is mostly not inviting citizens to participate, but are doing research on science-society interactions. And over here is a smaller cluster, but it says volunteer geographic information. So within geography and geographic information systems, there's a long tradition of involving non-scientists in data collection, and for example in OpenStreetMap, where you have crowdsourced maps. But the main bulk of research that goes by the name citizen science, which has produced the largest scientific output, once again we have to note that this is from the perspective of scientific publications, is biology and species conservation, and to a smaller extent astronomy and other natural sciences.
I think it's important to point out also, when we did this study, it's you can find it in PLOS. We also saw that we related the scientific output in articles to existing projects around the world. I don't remember how many projects there was, 700 or something like that. And we could also see also that the scientific output was about 10% of these projects had scientific output. So some of them are doing citizen science because of other reasons, for social change, local social change, for instance. Citizens collect data about their environment to take legal action towards industries or oil companies or whatever. We go into that a little bit further. So this is what we were interested in. Where in the research process is the citizen participating? As you could see from the expectations, it was about changing the whole scientific culture. Yeah, not really. We don't think so. Might be, but not necessarily so. And science is not democratic. As you know, science is meritocratic and epistocratic. It's a different kind of thing. But where in the research process is the citizen participating? We'll take you through some of these forms now of citizen science. And we have decided to kind of take them apart in participation in scientific research and issues about representation in policy or in other arenas or forums. So there's a difference between citizen science is used in both these with these two connotations. So would you like to say something here, Christopher?
So participation then could be seen as when science or scientists take the initiative and then invite the general public or segments of the general public to participate in a narrowly defined area of the research process. And here you will find these natural sciences that I talked about before, for example, astronomy or biology or various natural sciences that either have large repositories of data, which is the case in astronomy. You have, for example, the Hubble telescope, and these telescopes, they produce millions of images all the time of the sky, of galaxies far away, that are just being collected in huge databases of scientific data, which is impossible for scientists to go through and look at. So here you invite the general public, or you invite volunteers to contribute in classifying these huge repositories of data. You also have this in the humanities, where you have, for example, over there at the library, you have millions of books that are being digitized, millions of pages of books that need to be transcribed, for example, handwritings or that cannot be read through computer algorithms and cannot be transcribed without the help of volunteers. But you might have the opposite problem. You don't have enough data, which is the case when data is very expensive to collect. So for going out in nature to observe species, going out and covering large geographical areas, which is the case in Sweden, we have lots of forests. So going out there is very expensive. But if you have people that are already in the field, for example, ornithologists, or in Sweden we have lots of hunters, and they collect huge amounts of data about moose, the moose population, which would be extremely expensive for scientists to produce that kind of data. But if you have already an already existing community that are already in the field, already hunting, they can be involved as collectors of data. So citizen science has been used to tackle the problem of the limits of automation. When you cannot classify automatically, or when you cannot collect data automatically, there has been many successful large-scale projects involving volunteers to address problems of limited resources, but also being able to scale up. And this is where mobile technologies enter, because with smartphones, for example, you have a very ubiquitous transport layer for making observations. You have a camera and you have an interface, and you can report straight from the field what you see or what you observe, and you can also modify some of these hardware, the mobile applications, to collect other, maybe not visible layers of reality. And what's been a key element of these projects is to rely on standardized protocols. So a problem with scaling up observations or classifications is, how can we have thousands of people collecting or classifying scientific data in the same way as a trained scientist? So if I have a PhD in astronomy or in biology, I need to make to construct a protocol and design the scientific process in a way that an 11-year-old with no training, or people from various backgrounds, speaking various different languages, coming from different cultures, etc., need to do the same thing. Thousands of people have to observe the natural world in the same way. Otherwise, it's not useful as scientific data. So there is a constant process here of checking that these protocols are being followed and ensuring data quality. That's one of the key elements in this citizen sciences participation. But the non-scientists or the volunteer contributors, they are only invited in this segment of the research process. You get a protocol on your phone, or before the digitization, you had to fill out paper forms and return it using snail mail to the researchers. But this is the interface between science, the scientists, and the non-scientists, the scientific protocol.
Yes, and yeah, maybe I should say something about the limits of automation. I mean, you could ask yourself, why can't we use an algorithm to go through? I mean, this is from a project called Zooniverse, which is one of the more famous ones and more successful ones in terms of scientific output today. Zooniverse is about classifying galaxies. It's an Oxford project, and volunteers have done about 100 million observations or something like that, which is an enormous amount of observations which science themselves couldn't produce. And the thing is that you can't have an algorithm to do classic, to falsify an hypothesis. That's very difficult with an algorithm. An algorithm will just sift through what you program it with. But if you have the human eye, you can also find the anomalies, and there's a well-kept secret in astronomy or in other natural sciences also, that it is the anomalies that are interesting, that drives the field forward. So if you have a protocol that is determined by 50,000 observations, and then you feed it with enormous amount of observations, the protocol will not hold. There's no protocol that holds enormous amounts of data unless its explanatory value is super kass på svenska, super bad. But that is the way you do it. That's why you need humans. The limits of automation. You can't do it with algorithms. You can do it with algorithms, but it becomes very bad, very crude to do it.
Similarly, you have, in the case of species observations, there are, so for example, ornithologists or birders, they can differentiate between hundreds, sometimes thousands of species of birds, which is not possible to, you cannot fly a drone with a camera, and they cannot, the computers cannot classify species, because species differentiating various birds from, it's not possible to automate it. So you need certain skills of observations, especially in ornithology, where you also have, sometimes you don't see the bird, you listen to the singing of the bird, or the twittering of the birds, and there are people who can recognize or differentiate between species. So human perception is a key element in many of these. If you don't need human perception, it's much cheaper to just hire a big server farm of computers that will go through your data. But the human eye and ear and smell, etc., are needed in these projects.
Yeah. So this is the conceptualization of citizen science is very much now filled with a lot of expectations on the policy level. Another conceptualization of citizen science is as political representation. And if we go through the literature here, we see that what is driving this type of concept of citizen science is how controversial scientific knowledge or scientific knowledge that is deemed controversial needs to be opened up for in policy decisions for stakeholders. It's in Sweden we could call it medborgardialog. That's a way to represent citizen science also. So the different forms of knowledge that are clashing, for instance, scientific knowledge about fishing quota and the knowledge that is that professional fishermen have about their fishing quotas. So stakeholders are involved in the policy decision-making process. They are not involved in the scientific process in this conceptualization of citizen science. It's about deliberation as a way to handle the problems of the representative democracy in this type of decision-making.
And then there is if we have citizen science as participation and as representation, you also have another hybrid form of citizen science, which has been, it's very common abroad, not so common in Sweden, but that could be conceptualized as citizen science as social change, or when scientific investigations or inquiries are performed outside science as an institution. So non-scientists are doing science or using scientific methods, or at least being inspired by scientific methods to do something else, and often promote social change in one way or another. And here, these types of projects initiated by non-scientists are usually concerning some local experience. It's not about the big issues like galaxies or the ecology, but usually it deals with a very concrete problem. Like in my neighborhood, there is air pollution. Or in my neighborhood, the drinking water is poisoned by, there's a lead poisoning in the drinking water. Or in my local environment, there is too much traffic. So there are numerous of projects, especially in the United States and the UK, that have begun as identifying a local problem. We have a problem. And then, instead of writing a list of signatures, like collecting names, we get 1,000 signatures on a piece of paper, and we go and hand it over to the politician and say, well, we are 1,000 people. I represent 1,000 persons who think that there is too much traffic in our neighborhood. Dear politicians, please ban diesel cars or something. Instead of doing that, we have these cases of going and using scientific methods. So instead of collecting 1,000 signatures, these activists or social change communities collect data. So one famous example is the Louisiana Bucket Brigade from the United States. They, in Louisiana, you have these oil companies, Shell, etc., who have their refineries in the cities. And especially in some poor areas you have that are very close to these refineries, people started to experience that, well, you have trouble of breathing, we are getting sick here, we are not feeling well, but the politicians don't care about us because we are living, we are living in poor areas and we are being neglected. Instead, the politicians are on the side of the big oil companies who bring in a lot of profit. So what they did was, how can we measure? We have this experience of bad air quality and we have experiences of bad health. But the problem is that using scientific instruments is very expensive. Buying one of these sensors for measuring air quality, like the city of Gothenburg, they put these ones in the streets sometimes. They're very expensive, big trucks that collect air. But they were too expensive for these activists to crowdsource this type of scientific instrumentation. So instead they built, and I'm not sure you can see it here, but it's a bucket, plastic bucket, and you put inside, you put a sterile plastic bag, and you connect one of these small vacuum cleaners that you are using for vacuuming, cleaning your desktop. So you can suck air into the plastic bag, and then you seal the plastic bag and you send it to a lab, and you get back a report of all the various substances and chemical compounds that are in the air. And then they publish on their website the data. And managers, and then they take this data, instead of, they have this type of citizen science has no real interest in making scientific contribution or publishing scientifically. So instead of taking this data to a scientific journal, they take it to court. And then they sue the oil companies for relocation money so that they can be able to move out of these polluted areas. And they use the data in court instead of, so it's not scientific data, it's data that is being put to trial in court, which is probably a much more thorough review than peer review, because the oil companies, they have the most expensive lawyers and they will go through every single data point in your data set here. So here it's about using scientific methods for something else. Not for science, but for social change or getting relocation money or getting that oil refinery or fracking. There's a big issue of fracking in the United States, where these activists are actively sampling the air and saying, well, we can prove that fracking will put these gases out in the air and will affect the drinking water, etc. So, and there are many instances here, many, I think, exciting. This is a project called No Silvertown Tunnel. It's in London. They want to stop the construction of building another tunnel under the river, Thames, in London. So they put these diffusion tubes. It looks like a pencil like this, but it's transparent. They hang it up for 1 month in a lamp post. And it hangs there for 1 month, and the air goes into the tube, and then you take it down and you send it to a lab, and they get back the carbon monoxide levels, which they can then take and say, well, this is above the threshold level set by the European Union. European Union has this threshold level, and in this street where you have lots of buses going, it's more than that. So this is actually illegal to have this amount of carbon monoxide in the air. So these projects are, they have a it's not about participation, but here you have non-scientists designing the whole research process. But they almost always interact somehow with science. Because these tubes, they have to be sent to a lab, and this lab is run by scientists. Also these plastic bags here, they also have to be sent to a scientific lab. So they collaborate in one way or another with the institution of science, even if this takes place outside science.
So the issue of data quality is, of course, always present in these types of projects. How can you trust the data? How can you trust them when they put it there? Didn't they hold it just around the exhaust pipe of the cars, for instance? But that will be then detected by the laboratory, is the argument.
Also, these projects, we talk about open science and open data, and this type of research is very much in the open, because this is how they get support. So they publish their data immediately on their websites, which is open data, and they use the general public as reviewers, saying, well, we have nothing to hide. Here is our data, and it's going to go to court, and we're going to use it in these ways. So please review this as much as possible. So they have also the notion of extended peer review built into them. But yeah.
So there are at least three meanings of citizen science. We have the ones asking for help, scientists asking for help. Galaxies, birds, or whatever. It's very much about the protocol, disciplining the perceptions of people. People are mobilized with the natural abilities, almost, perception. But they have to be disciplined in protocols. It's about natural science. And the stakeholder, so to speak, is here an actor in science, a contributor. And it's very much about scientific output and the environment. But on the other end of some kind of imaginary continuum here, we have the political representation, the stakeholder, where you involve people in decision-making, like medborgardialog. Here, the stakeholder is a political actor. And then we have these types of projects that are growing from local concerns about environment and health, like the Louisiana Bucket Brigade or the Knowles Silvertown Tunnel in London, which is very much about getting local epistemic representation. They feel that this is not enough, so they go a little bit upstream here and find ways to get epistemic representation also. With local experience and do-it-yourself instruments and creating data then, which has to be of a high quality, otherwise it won't hold in court, for instance.
Can just add to this picture that it's very easy to know something, and to know about these projects, because they publish in scientific journals. So this is why it's so easy for us to know what these people are doing, because it's accessible. Here it's much more difficult, because since they do not publish in scientific journals, and they are usually scattered around the internet, and it's quite hard to know exactly how many they are and how many that are successful and how many are not successful. So here it's much more, we need to know more about these projects. And these projects are usually well researched by social scientists and science and technology studies. They have studied this form of political representation and stakeholder for a long time. So in the middle here, we know the least, and also because this is something that is a quite recent phenomena, especially when they're using the internet as a platform.
I've made a slide here which is about the models you have in your work, and models for stakeholder interaction in research processes. I think you have the old transfer model, you have the more recent interaction model. I try to find out and situate these models in what we have been talking about here. And of course this one seems a bit outdated then, because the knowledge production is not, I mean, the stakeholders are not here in the knowledge production as they are in many of the citizen science projects we're talking about here. And in interaction model, you also have, for instance, the formulation of research questions. Well, yes, to some extent in the Louisiana bucket brigades and the No Silvertown tunnel, you could say that they also formulate hypotheses. If you go out and you smell that there is something in the air, and then you decide, now I have to do measurements of the air quality at the playgrounds for our children, or in the way that our children are using to get to school. You can say that is a form of research questions and also problem formulation. And data from stakeholders are definitely influencing local policy and also litigations in court. Right. Yes, and this is research that is taking place in this project. It's a Wallenberg-funded transdisciplinary project here at Gothenburg University. And if you want, you are most welcome to contact me or Christopher to have some other papers to read, some papers that are in progress, which you can read, but maybe not cite them. And there is also some Swedish papers that's coming out of this project now. Thank you.
Well, thank you. Thank you very much. Let's open up for questions and comments.
Raise the light.
Yes.
If you want it darker.
Sure. Taking the opportunity, and I'm wondering about criticisms against this as a method of data collection or research. And if since I have the word, there is one sentence here that puzzles me a little bit more than all really. The only one that really stands out as something that I found a bit peculiar is in the paper that only 412 of 490 of the citizen science project surveyed do not have a scientific output. Is that a problem?
No.
Can it be called science still? If that's because I'm thinking that any kind of science would produce a scientific output. So I found that a bit puzzling. But okay, and that relates to my first question on criticism.
You mean if there's a criticism in people doing citizen science in terms of the quality of data, or
well, this as a concept and as a way to go forward in science, and also perhaps exemplified by that fact that so little of the citizen science leads to scientific output. Yes.
Yes.
Is what I'm interested in.
Yes, historically there definitely have been a criticism against this, to involve the non-scientists in doing scientific. How can you trust them? How can you be sure that scientific data holds water, so to speak? And it probably is that way now also. So there's the field now is very much about finding where in the research process the non-scientist or the amateur or volunteer contributor are on par with the scientist. If you are the scientist and I am a volunteer, how can we be doing the same thing? And I think it's important to point out that this type of data quality is not something that you attain in a person-to-person relation, but it is on an aggregated level. For instance, in many of these classification projects, you set the threshold for the data quality. If you, as a scientist, can make an informed interpretation of something like a crab or a mussel or something like this is an invasive species at the coast, you need maybe 14 or 12 observations by the non-scientist to get a mean value that resembles what you are able to do. So it's always a lot of complicated actor network kind of things that goes into this to find the right threshold for it's the construct of a threshold for data quality. But historically, you haven't been able to do this because of the lack of actually surveying what people are doing. But now you can do that because you have all this digital technology that makes it possible to follow each contributor in each project. Which also, we haven't gone into this, but this is also an issue that is growing now in this field about ethics. How much can you actually survey people that do this type of thing? Who owns data, for instance? These people, I mean, I guess Karl Marx is rotating in his grave because these people are working for free. There are millions of people working for free here.
But there was another aspect of that question,
Yeah.
I think.
I'm sorry.
If so many projects are not publishing scientifically, is it citizen science really? Or should it be called citizen studies?
Or public engagement or
and
something.
Yeah, but I think that many of these projects are small, so and they are designed not to be successful in scientific terms, but save this species of insects in this river, or make surveying how many bats are in the north of Sweden, or in these instances here, putting some data to an environmental problem. And so it's true that they don't have science as their goal, so they don't write journal articles, and they don't really gain from this. If they are initiated by non-scientists, they have nothing to gain from scientific publications. They won't make a career. They don't even have a PhD maybe. So their goal is to use the scientific methods to do something else. And if the definition of science is what is being reviewed as a science by peer review, is the definition of science, then it's not science. No. But it's science as scientific means, perhaps, is a better way. But they usually self-identify as citizen science, even though they don't publish scientifically.
And they usually send their samples through a scientific lab, so it circulates through science. Mm-hmm. But just to sorry, Barbara, but to just say something about the data quality. You see, there's a lot of projects here listed. Some of the ones that have large scientific output in terms of publications, but also a very big Swedish project is called Artportalen. Maybe some of you know of Artportalen. Artportalen hasn't got that much scientific output, but it has a tremendous societal output, because the data that is collected by citizens in Artportalen, because it's citizens, amateurs, ornithologists, entomologists, people that are out in nature, they collect enormous amounts. I think it's the third or second biggest. 45 million observations. Yeah, crazy, enormous amounts of data. This data is extensively used at the local and regional level in Sweden for political decision making concerning infrastructure, cities, buildings, stuff like that. Windmills, for instance, vindkraftverk, are built very much according to data that is not deemed good enough for science, but good enough for the societal issues. Sorry, no.
Okay.
But I think Barbara was.
No, I think Maria.
Okay, I'm sorry.
Anyway, in my question, I also write like the science and participation. I'm a human geographer looking into biodiversity, so I'm familiar with all these kind of Artportalen and ornithologists and so on. And I wonder, in your study, if you run into studies on the participants, what happened to them? Because, I mean, most of the time it's presented this brings something to science, but in my field of research is this extension of experience of nature-human relations, reconnect humans to nature, and I see this might be a way of doing it. So have you seen any studies of this? When I look for it, I haven't seen much, but maybe you.
Yeah, we are doing a couple of studies on what is happening on. It's an interesting phenomenon, if you talk about it in some kind of STS terms. People are mobilized into these types of projects with their natural abilities. So you mobilize citizens according to the natural abilities of perception. And that perception is then disciplined in protocols so that people do valid observations. That is what they are mobilized with. So the cognitive threshold to take part in many of these projects is extremely low. You don't have to know anything about galaxies to classify them. You have to know something about birds to classify them, though. So there is a different scale, of course. So they are mobilized with nature, but when they are in doing their projects, most of these projects have some kind of discussion forums. There a culture of contribution is created. And there people are discussing what they are doing, sometimes without researchers knowing, but mostly researchers are also there. The owners of the project are there to give advice and stuff like that. But what's happening there, we have very, shall we say, fun data, or whatever, fun data, if you can have fun data, in a project concerning the classification of galaxies. The way of mobilizing people into these projects are often, you can see something that no one has seen before. It's kind of exciting to be part of these projects. You can see something that goes beyond the protocol. And people do that very often. And then they say, they take that question of what they have seen into the discussion forum. And there they start to discuss. And we have very nice data. We have about, I don't know how many hundreds of thousands of posts we downloaded. We can see that people sometimes learn things that goes against them mobilized according to the natural abilities of perception. Because in this project they learn how to identify artifacts, artifacts in telescopes, reflections and stuff like that. Then they become so good at identifying them that they can identify from which telescope it comes. And they become better than the scientists at this. But at the same time, this type of culture of contribution and development takes them away from what they were once mobilized with. So it's kind of anti-program, or what? Yes. So there's an interesting. So learning is not. You can't control it in these projects, even though the argument is that you can often.
And also, in many of these projects, the scientists are tapping into specialized knowledges that are where the so-called amateurs have more skills in certain areas. So, for example, with identifying birds, you have amateurs out there who can identify many more birds than biologists that are much more skilled in this, being in nature, being out in the field. Also, like here in Gothenburg, I learned the other day, you have growing corals in aquariums, in saltwater aquariums. This is very important because corals are very sensitive, and you do a lot of research in marine biology on corals and under what circumstances they are surviving and what happens when you have climate change and water is going. So growing corals is very, very difficult in an aquarium. But there's a whole network of non-scientists that are doing this as a hobby, dedicated. They know everything about every little chemical compound in the water, about the temperature, etc. They are more skilled than scientists in growing corals. And so this is a very useful resource for scientists that need corals for their experiments. So the experience of nature, or the experience of the study object, is usually, in many cases, the citizens are more close to their study object from a sort of a phenomenological point of view.
I think it's okay.
Well, I have a sort of comment questions in three parts. As to biology and astronomy, I think I'm not very surprised, because the anthropologists a long time ago said that the well-instructed natives are oftentimes much better observers than doctoral students, although it didn't have a name then yet. But what struck me from the beginning, the obvious analogy of the term citizen science with citizen journalism, which, as you know, was taken by journalists as an attack on an already sort of threatened profession, and they did their best to I mean, the ideas, the sort of hopes were very similar. To the contrary, they were saying that the war reporters will not be as exposed as they are now, because the people who are already there will be reporting. But journalists were not pleased at all. No. And because, in this situation where most universities in many countries seem to feel sort of threatened, it could be also seen as a threat to profession, but you didn't mention any of that. And the last comment, which is related to it, if citizen science will sort of aspire to produce epistemic representation, that is truthful representations, in the in the sort of era of post-truth, it could be seen as the final sort of blow to, I mean, whether producing any facts are good and sort of multiplying the problem even more.
Yes, yes, definitely. There's been a discussion in the United States about this as being a threat to professional scientists. But this discussion often assigns the citizen a lot more abilities than they actually have in these projects. I mean, you must remember that citizens are only mobilized into very, very restricted and reduced parts of the scientific process, the legwork of science, which no scientists are. You can't force a PhD student to classify 50,000 galaxies over the weekend because they don't want to be PhD students anymore, maybe.
Yeah,
So
but that's facts, but
yes.
also about the image.
Yeah, the image is when it comes to citizen science, I think it's hard to. I was in Rosenbad yesterday, and yeah,
Exactly.
you can see that the new research proposition that is out now is highlighting this as one way of dealing with the open data and the big repositories of data, the abundance, the data flood we have that science can handle anyway. So it's just a help to science. So, but the issue of how this is affecting science negatively is really downplayed. If it is, it's really downplayed. The benefits of large data repositories that cannot be handled by science in itself is really the upward. But there's no one actually in Rosenbad, at least there was no one talking about citizens doing this by themselves, for instance, as in the bucket brigade kind of thing. That is kind of not on the map. So there's also an interesting how you choose to conceptualize this phenomena.
But what we've seen so far is that post-factual, what's interesting with these projects is that for them to be citizen science, they are more transparent than scientists with their data, because they cannot go, I mean, in one way, scientific knowledge published in scientific journals have this problem of being sort of obscure to the public. We published in, and it's all behind a paywall, and it's written very, you have to know much to read a scientific paper. But these activists or citizen science for social change, they have to do what we are struggling to do. They have to reach out with their data and then have it being very, very transparent and replicable. So otherwise, they cannot go to take it to court. They cannot convince the politicians if the data is not. So in one sense, I'm sure there will be bad citizen science in the future. But my hope here is that the transparency itself will make I think post-factual citizen science is impossible, because it cannot be science if it's post-factual. So using the scientific method, I think could be one way out of the post-factual sort of discourse that is.
Yeah. At least that's the kind of hopes. Yeah.
I'm optimistic, yes.
Yeah, it's very optimistic.
Dick, there was a question from our online participants.
Okay.
Yes.
And then sorry. Yeah.
I think we kind of touched on it with the first question, but the question here is there a difference between citizen science and co-production of knowledge? Is it actually the same thing, but citizen science is trying to higher, the quality of co-production of knowledge? That is the question.
Okay, co-production of knowledge. That's something really to discuss. What is co-production of knowledge? Is it the Jasonov definition of co-production here, or I really?
I didn't understand that co-production of knowledge is usually used in IBES text.
In what?
IBES text.
I don't understand.
I guess that's the Intergovernmental Platform for Biodiversity Ecosystem Services, where I'm.
Oh, okay. So it's not. Sorry, it's not the STS concept. It's not the. Then it's easier.
So apparently, the term co-production of knowledge is often
It's a new platform similar to IPCC, but focusing on biodiversity.
Okay, so
it's a more transdisciplinary notion of co-production. It's not the co-production of science and policy, but the
Mm.
co-production of knowledge by different.
Or just
disciplines.
competing fashionable expressions.
yes.
But it's co-production because it's science is collaborating with another actor. So it's a co-production of knowledge.
Yeah, transdisciplinary, I guess.
Yeah.
Transdisciplinary knowledge.
Yeah.
Yeah.
So is citizen science just another word for production of knowledge in this sense, or
Well,
this is something else?
no, not. It depends on what you invest. The concept of co-production with type of meaning, because it can be a very but I guess in this context, I would say,
this context, yeah.
I'd say
Yeah.
it would fit nicely. Yeah.
Citizen is missing. Co-production could be,
Co-production could be between any actor.
Yeah.
But the citizen here, the concept of citizen science is to kind of point out that there is someone who is not usually part of the endeavor of scientific knowledge that is now part of it.
Yeah, but the citizen has rights and obligations, and
Yeah.
is somebody who is living in a modern society. So it's in this sense it's different because you have the individual actor and his or her relationship to the institution of science.
Yeah.
Could you say that those terms are developed into various kind of fields of communities, of scientific communities, so there must be partly overlapping,
Sure.
but they're kind of not developed in the same
No.
scientific
No.
community. So
No, it's you
Yeah,
had
okay.
had.
Unless this discussion is not done yet.
Well,
Okay.
we can pretend. So you get.
To be the black hole. And
Yes, it's a black hole. We can.
Yes, it's a massive. No, I have a question first and then a comment after you have answered it. Have you looked into how different research communities have reacted towards citizen science? As in some, of course, disciplines it's a big no, and in some it's a big yes. What are the general opinion about citizen science and the function of citizen science?
Just say a few words, and then you say a few words. Yes, I've been involved in some projects in medicine, and there it seems to be a very difficult concept to do citizen science, mostly by ethical reasons, personuppgifter in medical journals and stuff like that, and also there is it seems like the people are very protective about their data, don't want to share. And also in the humanities there has been a bit of the humanities. We haven't talked about humanities here. We could have included that also, but the humanities have not been, how should I put this, as successful as some of the natural sciences in doing this. But there are citizen science projects in the humanities, and they're mostly about transcribing, difficult text into digital text, so that you can actually construct databases, or it's about data tagging, for instance, archaeological findings and stuff like that on the net. Because that ties into the big discussion about digital humanities, being humanities or not being humanities. It's very much about boundaries between what is and what is outside traditional humanities. So there are some areas where it's not medicine. There are some projects in medicine, but they are, if you get it wrong in classifications and data in medicine, people are very, yes. You don't blow people's minds, you blow people's, whatever, hearts.
But the pioneers are definitely the natural sciences, and have been historically and are in terms of scientific output. They have the highest scientific output, and they have the highest number of participants. So and they've been doing it for a long time. So there seems to be a very it's very natural to the natural sciences to involve non-scientists in the research process. In the social sciences, there's another problem, because the social sciences have the citizen or the people as their study object. And in citizen science, you involve them to create and collect data. So they become study or co-scientists, or as the social sciences have a difficulty of establishing the identity of normal people. This is a very interesting paradox, because social sciences study people, but they have a problem with collaborating with people because because the study object, but the study object becomes the study subject. So so in sort of survey research in social sciences, survey methodology or interview methodology, social scientists are used to have people respond to their questions. But now, in citizen science, they are data collectors, data classifiers, and that is sort of not in the social scientific tradition. But I think that's probably changing.
Yeah, that is changing. There are
social science is not only studying on people.
No.
But,
and the question that social sciences pose may come from real life problems of these people.
Definitely.
Exactly.
Yes.
Exactly.
That's a long tradition.
Yes, there's a long tradition, of course.
Yeah.
There are some social science, citizen science projects, so to speak, around. But they have been also quite controversial. For instance, there have been apps for harassment apps, or unsafety mobile apps that you click things when you feel unsafe in the urban landscape and stuff like that. And the data quality there has always been, if you always move in some areas, for instance, that becomes, so, and also the harassment app has been very much criticized. So there's always the problem of the natural sciences have a long tradition of trying to secure the data quality, but you have all these expectations of these kinds of projects, and on the other side of that coin is how about data? How about data? So
I have a follow-up.
Yeah, your comment, yes.
Just because.
I'm sorry. Yeah.
Well, yeah, just related to the whole, can we call it science or not? And then again, or related again to the question, can we trust the data and the data quality? It seems to me that but a central important discussion here would also be the overall what is science debate. And it seems to me a little bit, after some papers about the subject, you read often, or you come to this discussion again that just like qualitative research has have often sort of been the soft version of more quantitative research base. Is it really research? Can we really call it research? It's sort of like citizen science has become the new soft research approach.
I understand.
And that requires some kind of identity crisis solution, that what are we actually producing here? And can we call ourselves research at the same level like other kinds of research? And could be interesting to actually showcase it by having scientific research done with scientific research methods, compare that with social science, citizen science-based methodology and results, and actually see that the worst case scenarios in normal science, what we call science results, actually is a lot worse than the best results, obviously, from citizen science. And that way, so you can actually see the weighing of the two, and you can actually argue for these two things.
Yeah.
So that's my comment.
Okay,
thank you.
So if someone in Beck, for example, there are a lot of natural scientists around who would like to
you mean Beck,
learn
this
strategic research area, which will now continue for 4 more years.
I thought it was the German
University of Gothenburg.
Beck.
Then if they would like to start using or collaborating with the citizens in collecting data, for example, where would they turn to learn?
Please, to us. No, but
how to set up protocols and
about
it.
There are several projects at Gothenburg University doing this already, mostly in the biological sciences. The largest project in the humanities is done by Christopher here. He can tell you more about that. So there is a community of people doing this at Gothenburg University. And by the way, we are going to a workshop now in Berlin in the middle of December to learn more about protocols and stuff like that. But we're also working now to set up a center for citizen science at Gothenburg University, where we could pool these types of resources, software, hardware, but also the critical studies on this phenomena. For instance, aspects like the ones Barbara took up. So a transdisciplinary or multidisciplinary and transdisciplinary center, national center for this, to see what can actually be done, and also to meet some of these expectations on a more realistic kind of, how should I say, level or so. There's some things we don't really know about this. We don't know. There's no more systematic studies of the values produced in citizen science. How do people that are involved in these projects, what kind of ideas or values of science or society do they produce or co-produce in these types of projects? And what does materialities in citizen science do to the scientific knowledge or the knowledge produced here? There's a lot of questions that needs to be addressed in this.
Okay. So 2 more questions here, Maria and Anders.
Yeah.
Yeah. Okay. So would you say that citizen science is almost like a global phenomenon? And
Definitely.
yeah. Okay. Because if you use it, even if you get public, if there's a publication or not, if you use it as a social movement, could you say that is it more common, for example, in democracies where you already have, hopefully thriving civil society, or is this actually a method for empowering people who lack rights?
Very, very interesting question. I say two words about this. It is a global phenomena in all these kinds of meanings of citizen science. We had 3 forms here. And when it comes to the scientific form, when people are asking for, when scientists are asking for help, it's definitely, they are now a European Citizen Science Association, and an American one, and an Australian one. They're starting their conferences, and they're starting their journals and stuff like that. So all that is happening in kind of formation in the Kuhnian normal science kind of thing. But the thing with democracies is very. I was in the US at their first inaugural conference. And that was a conference that was really marked by social change. The whole conference was about social change. How can we use citizen science as social change? And there were some really scary examples of people doing citizen science. For instance, I think this was in China, and I think it was about the environmental thing. And the scientists just collected the data and then they left. And the people that had collected the data were, of course, now recognizable by the Chinese government. And there's a lot of things that, and ethical and other things that you can go completely wrong with these types of. They were empowering them, but they were also putting them in prison.
I wrote an article about citizen science in this activist sense. I can send it to you, but there you see it's more powerful in non-democracies. So for example, in Peru, you have these indigenous people that there is oil companies in the Peruvian Amazons. They are spilling out oil in the rivers, and these indigenous people are using citizen science as a way of mapping up terrain that was not on the map before. So saying, for example, this is the territory where we live. They use geographical information systems. Also in China, you have this, it's forbidden to make a protest against the heavy pollution. But so instead, the citizen scientists started to take samples from the river, and because they were saying the water is getting polluted because upstream there is a factory releasing these toxins into the water. But they couldn't make a protest in the street because making a protest is forbidden according to the law. But they could take water samples and bring it to the government because that was seen as non-political. This is also the case in Thailand. You have the Mekong River. And upstream of the Mekong River, the Chinese are building power plants, which is making the fish. The fish cannot go up and reproduce. So, and these communities that live off the fish, they have this problem that in Thailand and China, it's not. You cannot make protests. You cannot have civil movements working there because then the police will come. But just publishing data on the frequency or the sort of the which species are coming and going and how the dam is affecting this is seen as a non-political sort of move. So in a sense, citizen science can be more efficient in non-democracies where it's forbidden to make a protest.
And
you cannot have 1,000 signatures because then you can put...
Yeah.
There's one more question.
Okay, well, just say one familiar example of how citizen science changed or put policy on, how should I say, criticized Fukushima, of course. The government didn't really release their data of radioactivity. So people bought very cheap Geiger meters from Russia and used mobile phones to collect data. So they could collect data and they could then see that it was, of course, much more polluted than they thought it was. The government, of course, knew of this, but they didn't release this. So there is there's a lot of things that, and of course, that is not science, but it is definitely using science for something. And this is also the way these communities are using science. It's also a very interesting way to think about scientific knowledge as constructions or social constructions in the STS field. If people actually are dying, maybe it's not that so problematic to use, to take science as a certainty or something like that. Or there's a lot of things one can discuss there. So
One final question, maybe without an answer even.
Yeah,
okay,
maybe,
I like these ones.
Food for thought. But if this is science which does not always produce research outputs in the normal way we understand it, and a lot of it is data collection, generation of information, then I'm wondering where the line is drawn between what you have described in the examples and the data that we are generating all the time, being consumers, being citizens, being holders of iPhones, picking up money, buying stuff, and we know that data is generated and eventually it reaches research institutions. It comes as databases to us, researchers, if we want, from the government because they collect data. And we are providing that data. We know that we do that.
Yeah.
Sometimes we can say no, but in most instances we cannot say no, or we say yes because we think it's okay.
Yeah, because we like to be on Facebook, we say yes.
Yes, and medical. I'm going to the doctor. I'm getting treatment, but so that line between this going into forest counting birds and other examples. It's more than that. You mentioned some, but just being a citizen now generates big data in all fields. Security. NSA in the US. Companies selling stuff. Facebook. The governments, I'm declaring my incomes, all that generates data. Is that also social science?
No.
Citizen science. Sorry.
You can draw a line here that is. If we could do, if Christopher and I could do on citizen science data, so to speak, when people are contributing, to scrape that thing down the way Facebook does with our data. That would be nice, or maybe not, because we will get so much information that will be sensitive. So we can't do that. So there's a line according to research ethics.
Yeah, but there's also a line in sort of the scientific ethos norms. Sort of the Facebook data is proprietary data. It's we cannot use it for scientific purposes unless we know how it was made, and that's kept a trade secret. With citizen data, each step of the data generation process is transparent, just like in the scientific method. So,
ideally,
So it's generated in the open versus having a proprietary generation, which makes it very difficult to. If you want to use the data from social media for research purposes, you have to say, well, there's a black box here. This is how Facebook has constructed the data. I'm not allowed to see that. I'm only allowed to see the output of the data. So that's
We'll leave it there for
Food for thought.
thought
Food
and
for thought.
further discussion.
Right.
Just before we end, you mentioned, or you showed this one, you said that you use, and these two models comes from a survey that we conducted last year among environmental or climate change oriented researcher at Chalmers, University of Gothenburg and Lund University. And from that data we could kind of distinguish two broad groups of researchers. One that we could say were using, or the question was, when do researchers involve stakeholders in the research processes? And one group of researchers we classified as using a more traditional transfer model, and the other ones were using a more of an interaction model. So that's why where it comes from, and we're also using that in a guide for stakeholder interaction in research processes that we are developing, because we are trying to support researchers that want to work in a more systematic and strategic way with stakeholder interaction. So maybe we should add a participation model. We'll see. Okay. Thanks a lot for great presentation, interesting discussion.
Thank you.
We are at the Center for Environment and Sustainability thinking of continuing this kind of seminar series on stakeholder interaction in research processes. If anyone is interested to be on an email list and so on, you can tell me or put your name here. Do not be super ambitious seminars here, but maybe couple of seminars per semester or something, in order for us to learn more and for others as well. Okay, thanks a lot for your contribution.
Thank you.